In this section, we go a little farther into percents than we have before. And what I want to remind you, well, I don't think I'm going to remind you, but there's two words that we're going to be coming across a lot. The word is the same as equals, and the word of is the same as multiplication. So those two symbols we're going to keep handy. While we're at it too, there's a couple other things that you might find useful. 1% is equal to 1 over 100. Remember, that's 1 out of 100 or 1 per 100. But that's also equal to 0.01. Another very interesting aspect of percents is that 100% equals 1. So keep these in mind while we do these problems. Now, to solve these word problems, they're not really word problems, we'll get to those soon enough. We have something like this: 45% of 688. For this one then, do exactly what I wrote above. 45%, you want to change it to a decimal, so I'll do 0.45, and the of means multiplication, so I'll put a dot, 688. To finish this multiplication off, I'll do 688 times 45, and then I'll handle the decimals when I finish this. So let me go ahead and start. 5 times 8 is 40. Carry the 4. 5 times 8 is 40 again, so this time I get 44. Carry the 4. 5 times 6 is 30, so I get 34. Bring down a 0 for my next row. Now the 4. 4 times 8 is 32. Bring up a 3. 4 times 8 is 32 again, plus 3 more is 35. Carry the 3. 4 times 6 is 24, plus 3 more is 27. So I'll carry all of my numbers down. I only need to carry over 1. So it looks like I get 30960. But remember, the original problem had 2 decimals in it. So going here, I have to go and take my decimal and move it to the left 2 places. So this equals 309.6. Another example, 165% of 72. That equals 1.65 times 72. And let me go ahead and do my multiplication here. I'll insert the decimals later. Let's see, 2 times 5 is 10. I'll carry the 1. 2 times 6 is 12, plus 1 more is 13. 1. 2 times 1 is 1, plus 1 more is 3, so I get 330 for that row. Moving on, 7 times 5 is 35, so I'll carry a 3. 7 times 6 is 42, plus 3 more is 45. Carry the 4. 7 times 1 is 7, plus 4 more is 11. So when I add up all these things, I'll get 0.8811. But now come back to the 2 decimals that I had in the original problem, and I take my decimal and move it back 2 places to right there. So I get 118.8. I don't need the 0 after it, so I didn't include it. %, of 162, that's 0.42 times 162, and so 162 times 42, 2 times 2 is 4, no carryover, 2 times 6 is 12, carry the 1, 2 times 1 is 2, plus 1 more is a 3. Bring down a 0. 4 times 2 is 8. 4 times 6 is 24. carry the 2. 4 times 1 is 4 plus 2 more, there's a 6. And when I add these up, and then once again I have to move the decimal 2 places. 1, 2, so I end up with 68.04. Now while I'm working here, I'm going to go into the textbook and grab some of the problems out of it. I want you to, you can see where I'm going to anyways. If I go into Alex, give it a second while it gets in there. And then I'll pick the class 0910. This is sort of also to remind you where to get our textbook. It's a good resource if you should ever need it. Now I'm in chapter 8, the percents chapter, and right now we are working on section 8.3. And I wanted to grab some of the problems out of this. So the first one, well, actually I was going to, but now I'm not going to. Let me grab another one out of the book. So the word problems, it's always a matter of knowing what information is pertinent and what information is not pertinent. So this one here, I'll grab it from number 14? I'll grab more out of it. I just want it to be handy. So what we have here is that 10.8% of high school students in the United States smoke cigarettes, is what it says. We have 1,650 students. How many would be expected to be smokers in this thing? So you would expect 10.8% of the school population, which is 1,650. And you can see you can write it just the way I was doing. This is 0.108 times 1650. So as usual, I'll multiply it all out, ignoring decimals until I get to the very end. Starting with that 8, I'm going to have 8 times 0 is 8, 8 times 5 is 40, carry the 4, 8 times 6 is 48, with 4 more is 52, carry the 5, 8 times 1 is 8, plus 5 more is 13, drop a 0. Oh, this is good. This line's all zeros, so not much to do in that one. Then I'll go to the next line, which had 2 zeros. And, well, that's just 1 times everything, so that's not so bad. I'll have 1 times 0. That'll be a 0. I want to make sure my numbers line up. And then 1 times 5 is 5, 1 times 6 is 6, and 1 times 1 is 1. Let's add all these things up. I get an 8, a 0, a 2, an 8, a 7, and a 1. And then what I need to do is move the decimal 3 places to the left. 1, 2, 3. Put my dot there. And we have 178.208. Now, whenever you're working with a problem, real life problem, is you should look to see if your answer makes sense. We're talking about students here, so it's impossible to expect 0.2808 of a student to do anything. In fact, if you look here, look at the last line, round it to the nearest whole number. So what we would use, if you look, the 8, and then if you look at that 2, that says to round down. So, well, it's a bad looking down, but hopefully you get the idea. I'll see if I can write down a little better. So round that down to 178. Now for a little more practice. Some of these, you have to be careful when you're computing from percents to decimals. So here the units are like cats in this particular problem. 0.03 or 0.3% is not 0.03 but 0.003. And the of is times 9,000. So I want to do 9,000 times 3. And I'll get 0, 0, 0, then 3 times 9 is 27. Now what I want to do is move my decimal left 3 places. 1, 2, 3. And that'll equal 27. But don't forget cats. Now we're ready for some equations. With equations, keep this in mind. The word is the same as equals. So for each of these problems, I encourage you to rewrite the statement on a piece of paper. Watch what I mean. 12 is 40% of what number? So when you break it down like this, the numbers themselves come down. 12 is 12, but put an equal sign after it. Convert your percent to a decimal, 0.4. You can put a 0.40 if you want, but you don't need that 0 after it. 0.4 is good enough. And plus, since I'm going to be doing some stuff after it, having more decimals is not helpful. Having of be the multiplication. And when you say what number, we'll put an X there, since I don't know what number we're talking about. Well, to solve this equation, it's stretched out, but it's still 0.4 times X. You do exactly like you did before. And so that will leave X by itself because the 0.4s will cancel out. And you have to do 0.4 into 12. Remember the trick here, you don't actually do division with the decimal on the outside. You move this decimal over 1, and the same thing in here. You move whatever decimal was there over 1 as well. And you're going to get 4 goes into 120. And there's still a little bit more to learn here. Even though you might think you know long division, there's some tricks of the trade still. 4 goes into 12 3 times. Now what do? There's nothing to bring down. What do? You still have a space left here. Technically speaking, you could bring down the 0. 4 goes into 0, 0 how many times? 0. Well, 0, 0 minus 0 is 0. So I guess you could say this goes in exactly 30 times. So there's your answer. And so those are the types of equations that you're going to have here. And they're all the same thing. I mean, it's impossible even to ask questions about percents without having them into this kind of a format. I can't even come up with more incredible ways of asking than just these. So we'll just move on, do hopefully enough of them to where you'll feel comfortable working them. So here I have 180% of what number is 63. Now you're there taking your notes right now. Please make sure that you write down that whole sentence and then copy underneath of it the numbers and whatever words turn into math. So the 180%, I'll convert it to a decimal, 1.8. You could go 1.80, but it's not necessary. Of is a multiplication. What number, as we've discussed, is X? Is equals 63. Just bring it down. To get X by itself, I will divide by 1.8. So 63 divided by 1.8, I don't do 1.8 into 63. Instead, I do 18 into 630, so make sure you moved your decimal places. 18 goes into 63, let me see, 3 times 18 is 54, so 3, that'd be 54. 9, I can carry the 0. 18 goes into 90 exactly 5 times, so I have no decimal to speak of. and I end up with 35. Next, we have 6 1/2% of what number is 143. Same deal as before. Now, I was fighting with what should I do with this. 6 1/2, it's easy enough to convert that to a decimal. But I think a better tact or a better plan is the following. Whenever I'm dealing with fractions like this 6 1/2, that's being multiplied by 1%. So 1% I'm going to change to 1 over 100. Then I've got my multiplication, x equals 143. Now before I do anything else, let me change that 6 1/2 to a fraction. Remember the rules. 6 times 2 is 12, and then you add 1 to it is 13. So it's 13 over 2 times 1 over 100. And then I've still got the times x equals 143. Now there's no simplifying I can do here. I can simply write this as 13 over 200 times x equals 143. Well, these kind of problems we've done before. I can multiply both sides of the equation by 200 over 13. That way, these 200s will cancel, these 13s will cancel, and you'll be left with x all by itself. On the other side, what might not be a bad idea is to write the 143 over 1, and then note that 13 goes into 143 exactly 11 times. So then we have 11 times 200 and you end up with 2200. And there's your final answer. So I think when you have fractions, use the fraction version of a percent. When you have decimals, use the decimal version of a percent. Let's go ahead and do another one just like it. This time I have 322 is 80 1/2% of what number? So the same deal, I'm going to have the 322 is 80 1/2 times 1 over 100. And then the of is the big multiplication. What number is x? Now let me change my 80 1/2 to a fraction. So 80 times 2 is 160, plus 1 more is 161, over 2 times 1 over 100 times x equals 322. 322 equals 161 over 200 x. So I'm going to multiply both sides by 200 over 161. I'll put a 1 under the 322 to help. 200 over 161. So on the right hand side, all those cancel. On the left, 161 goes into 322 twice. So you get 400 equals x. Next we have 18 is what percent of 60? Now let's see what we have here. 18 equals x times 60. Divide both sides of the equation by 60. And let's see what we get. So it's probably, unless you're willing to go right to decimals, which you might want to, because the decimal version of a percent, well, the decimal version of a number, you still move the decimal over 2 places to the right to get something bigger. So I think going into a decimal is a good idea. So to do that, I'll have to go 60.0, because then, and I went upside down anyways, the 60 is on the outside. And then I'll get 18.0, which is good because 60 goes into 180 3 times. And that leaves me with 0.3. Now, the issue is this. Notice what it was asking me. What percent? Not what number, what percent. So we have to change 0.3 to a percent. Well, the way you do that is you start with your 0.3. We've talked about this before, and you move the decimal over 2 places. And then when you go past a spot like that, you have to fill it in with a 0. So this is the same as 30%. So these problems that I'm doing right now are just slightly a little bit different than the previous problems, because now you're not asked for what number, but what percent. So you have to remember, change your answer to a percent when you're done. Let's go to the next one. What percent of 300 is 222? Well, let's see here. I've got x times 300 equals 222. I'll divide both sides by 300. Now at this point, you can simplify, but remember you've got to change it to a percent. Now, I'm going to do something slightly different from the last one. If you want to change to a percent while you're dealing with a fraction, you do this. This is the same as 222 times 300 times the number 1. Why do I put that number down there? Remember, I said when you're dealing with fractions, it's helpful to work with the fraction version of a percent. Well, remember that 1 is the same as 100%. And I can put it over 1 to make life a little bit easier. Well, see, now I can cancel the 100 into there and leave a 3. So I have 222 over 3%. Now that's a very weird kind of an answer, but it's correct. If I want to get it into a more reasonable answer, probably one that is more likely to be accepted by your instructor, I would do 3 goes into 222. And when you're doing this, 3 goes into 22 7 times. And then 3 goes into 12 exactly 4 times. So look at that. Our answer then is 74%. So look at what I did there. The last time when I did the division, I went to a decimal and got the decimal version and used that in the problem. I also, the next one right after it, I left it as a fraction and decided to work with them that way. So you should be able to do them in both ways, but of course you can probably pick which one you're more comfortable with. It looks like when we went to fractions here, probably because I was explaining more, it looks like there were a lot more steps to get our answer than when I went back here. It looks a lot shorter to have done this problem than this problem, even though they're practically identical in nature. So maybe the fraction version is a little more complicated, but maybe it's something, it will probably end up being your choice what it is you'll be allowed to use. So I'll just kind of go with whatever I'm feeling at the moment on which way I'm going to put my answer. What percent? So remember, at the end, I'm going to have to change to a percent of 102 is 153. So I've got x times 102 102 equals 1.53. So I changed that. Oops, I made a mistake here. This here should be a question mark. So that screws up everything. Question mark. And then I'll put a 153 over here. Divide by 102. Divide by 102. And so I'll have x equals, well, let me do my 102 into 153. 102 goes into 153 exactly once. 102, 51, and then bring down a 0. Remember, put a dot, decimal, 0, bring it down. 102 goes into 510 exactly 5 times. And so x will equal 1.5. So in this one, I decided to go with the decimal instead. It seemed a little bit easier to me because I could see that it was going to end pretty soon. Well, remember, we have to change this to a percent. So move the decimal 2 places to the right to get 150%. My next example, what percent of 2,500 is 130? So we got x times 2,500 equals 130. Divide by 2,500. Now, one thing I do manage that for me is really easy to do is I can cancel out a 10 from the numerator and denominator and get 13 over 250. That saves me a little bit of time. Now, I think when I'm doing the long division here, let me see where I end up to determine if I want to go decimals or a mixed number. Or stay with fractions. Let's see. I'm at my 1, 3, and well, since 250 doesn't even go into 13, I guess I'm going decimals. At least I need something to actually go into it. So 250 doesn't even go into 13.0, so I've got to put a 0 here, get another 0. Finally, 250 does go into 1,300. How many times? Well, 5 times 250 is 1,250. And then when I do my subtraction, I've got to make this into a 10 and that a 2. So 50, add a 0, bring down a 0. 250 goes into 500 exactly twice. So this is 0.052. Now to get it to a percent, which was required by the problem, I will move to the right 2 places, and we will get 5.2%. Next we have what percent of 135 is 162. So I get x times 135 equals 162. Divide by 135. Divide by 135. This is a possible candidate to go into a mixed number. Let's see what the numbers yield when I do the division. 135 does go into 162 exactly once. And then I'll have 17. Now, if that, so that would be 1 and 17 over 135. Then you'd have to change that to a percent. I'm not sure that I want to do that. That seems very rough. So I think I'm going to go with the decimal. You can do whatever you want, obviously. Add a 0 and then bring 1 down. 135 does not go in to that exactly. Let me see. It goes into 170 once. And then let's see what we have. 135. I've got 35. Add a 0, bring down a 0. And then 135 goes into that exactly how many times? 162. Let's see, 135 goes into that. Let's see, twice. Get 270, 80. Add a 0, bring down a 0. And then 135 goes into 800. Let's see, 6 times. Let's do 6 times 135. 0, 3, 18, 21, 2, 6, 8. 8, 10 is too much, so I got to go in there 5 times. So 5 times 135 then is 500, 650, 675. So I get 125, and I can bring down another 0. How many times does 135 go into 1250? Well, I'm guessing 9 times, or at least 9 times. Let's see, 9 times 135. We have a 5, a 4. 9 times 3 is 27, plus 4 more is 31. Add a 3. 9 times 112. 1, 2, 1, 5. And then what's going to happen here? I'm going to get 35. Add a 0. And I should have put my 9 there. Add a 0 and bring it down. And then we're going to have 135 goes into 350 twice. And I'll get 270. I already did this before, 800. So it's going to start repeating. So what I'm going to have here then is x equals 1.2, I'm sorry, 1.1259. And then it's going to do it again. It's going to go 259. 259. It's going to do that forever. So this will equal 1.1. I can put 259 under a bar because that's the repeating portion of it. So that's what x equals. When I want to change x to a percent, then I have to move the decimal 2 places. So what I would do, let me do it here first, and then I can tell what the decimals are going to be. So x is going to equal 112.59259 percent. So now to see what is actually repeating in this, the 259 got chopped in half there. You don't put a bar before the decimal. So the 259 doesn't start to happen until here. So I can take all this stuff out and put my percentage after it. So that was about as bad as they're going to get. One last one. What is interesting here is the problem that I just did was a mistake. I made a mistake when I wrote it down, but I decided to roll with it. So it provides us with the hardest example, perhaps, that you're going to have. The actual problem it was supposed to have been is this. $102. And you'll see these steps are no different. But the number that I get in the end will end up probably being a lot better than this. And for some reason, 102 does not want to write 102. Let me divide by 135. 135. And I could do like all the other ones. 135 goes into 102. And then it does not go into 102. So I can add a 0 and see how many times it goes into 102. Oh. Well, let's see. 7 times 135. That's 5. Carry the 3. 21, 24. 2. 7 plus 2 is 9. 945. Add another 135, and that's too much. So let me put my 945 and subtract, make that into a 5. This isn't a 1, but it'll have to borrow to make an 11. And more borrowings would have to occur. 11 minus 4 is 7. It looks like we were 75 shy. Now I'll do it again. Add a 0, drop the 0. 135 into 750 goes how many times? Let's see. 135 into 750 goes twice, 3, 4. You see 4. Let's try 4 times 135. I think 5 is too much. No, 5 is not too much. I can do 5 times 135. 5 times 135 is 500, 650, 675. So, oh, look at this. Now we're going to get in the same situation here. I'll have to do the 5 again, 675, 7. So these 750s keep coming down. So that means we're going to get x is equal to 0.7555 forever. Change it to a percent, so we'll have to move this decimal to the right 2 places. So x equals 75.5, and those 5s go on forever, so I'll put a bar over the 5 and finish off the problem that way. As I said, that was what the intended previous problem was supposed to be. Well, anyways, I've done enough equations there, I think, for you to get the idea on how to do them in your homework. Now I'll move on to what I think is the last section of the course, and that is 8.4. And this is where we solve application problems. Involving percents. And this is where I really wanted to start grabbing problems from the textbook. So let me go into the textbook. Let me show you, if you're in a section in the textbook, it opens in a separate page like this. Check this out. If you go up here to the arrows to go to the next page, it takes you actually to the next section. So I can click it and it takes me right to 8.4. So all I want to do is get down to the homework problems and start working these things. So let me go ahead and grab them. My first one I'm going to grab is number 4. Whenever you hear that sound, it means it's been copied. So let's throw it here. And this course is number 4 from your textbook. All right, and what we're going to try to do is frame this in the type of problem that we've done. So what we have is we've got a total of 53,000 workers in Berkeley, and 8.9% of them. There it is right there. That's the whole problem in a nutshell right there. 8.9% of them ride their bikes to work. Well, who's them? Well, that's the 53,000 workers. So this turns out to 8.9% of 53,000. And that's all there is to it. There's no equation to solve or anything like that. Basically, I have to do 0.089 times 53,000. And so when I'm doing this problem, then I'm going to do 89 times 53,000. Of course, 9 times 0, 0, 0 still gives us those 3 zeros, but then 9 times 3 is 27. Carry the 2. 9 times 5 is 45, plus 2 is 47. So there's one line. The next line, I throw down my 0, and now notice I'm going to get 3 more zeros in a row, so try to line them up with the row above. There's my 3 zeros. And then I'm going to do 8 times 53. So start with 8 times 3 is 24. Carry the 2. 8 times 5 is 40, plus 2 more is 42. Then add everything up. 7, 1, carry the 1, 6, 7. And what do I end up with? Well, when I did the 0.089, that's 3 decimal places that I have to take out of here. 1, 2, 3. And it looks like I will get 4717. That's how many people ride their bikes to work. That was a pretty easy problem. The next one, it's not exactly the way I show my students to do these types of problems. The next one I'm going to grab is number 8, and let me do that one according to the way that I try to have my students set up their problems. And I can see number 8 is going to go with this picture here too. So let me first grab the picture and the description. There's that. Now let me actually get the words to the problem, which was in there. Problem number 8 is the one that I wanted. And then we'll read through it and see what it says. I think I'll put it over here and increase its size. There we go. Now let me go ahead and work this problem. All right, let's see what it says. We've got 28,500,000 non-elderly uninsured Americans. And the pie chart shows you which ones those are. It shows you the breakdown of these people that are not insured. So this entire pie chart, the entirety, deals with these 28,500,000 people. Use this information for exercises 7 through 10, and we've grabbed exercise 8. It says, how many of the uninsured were African American? So what I have to look for is there's 15% African American in this pie chart, and the whole pie chart is 28,500,000. So we're looking to get 15% of 28,500,000, or 0.15 times 28,500,000. Now, when you're doing the multiplication, I've often set them up to where I will drop the percent or the decimal on the bottom number, but for the top, I've left it all the way out. What I'm going to do this time is just work on the 285. The reason why is here's what I'm going to do. When I'm done, I'm going to move the decimal left 2 places because of those. But the zeros tell me to move the decimal right to the right 5 places. So left 2 places, then right 5 places is a net of 3 to the right. Let me go ahead and do the multiplication. 5 times 5 is 25, carry the 2. 5 times 8 is 40, plus 2 is 42, carry the 4. 5 times 2 is 10, plus 4 more is 14. Bring down the 0, and then 1 makes this an easy thing. 285. 2 plus 5 is 7. 4 plus 8 is 12. Carry the 1. 4. Now, as I said, here's what we're going to do. If I move the decimal 2 to the left, 1, 2, I've got 42.75. Now then, I need to move 5 places to the right. So I'm going to have 1, 2, 3, 4, 5. Actually, let me do that with a little more careful. There's 1, there's 2, and then we're going to add 3 zeros because we still have 3 more places to go to the right. So we end up with 4275 with 3 zeros after it. So there is 4,275,000 is how many are accounted for among the African Americans who are uninsured. Let me continue. The next problem that I want to do involves teenagers, so let's see what we have here. Right here is our next one. These are teens versus adults views of cell phone use. The reason why they're presented like this is the information presented in newspapers and things like that is often presented quite closely to what we're doing. They'll have percentages and things like that all of the time. Now, let me see what problem I wanted. Number 12, I think, is what I'll grab. And let me make that a little bit bigger. There we go. All right, so let's see what we have. The table below compares the attitudes of adults 18 and older to teenagers' attitudes with regard to cell phone usage. Let's see what number 12 is asking us. We're comparing two equally sized groups of 1,200 adults and teens. When they say 1,200 adults and teens, they mean 1,200 adults and 1,200 teens. Keep that in mind. How many more adults are expected to like their cell phones? Their cell phone makes it easy to arrange plans with. The way I said that was wrong. How many more adults are expected to like their cell phone? Because, I guess, how many more adults are expected to like their cell phone plans? So let me see. I like my cell phone. Makes it easier to arrange plans with other people. I like my cell phone. Well, you know what? They need a comma in there. Someone put one in. It was stupid. Anyways, 88% of adults believe this, and only 84% of the teens believe this. So we have 88% of 1,200 are the adults. And then for the teenagers, it was 84% of 1,200. So let's do these multiplications. I'm going to do 88 times 12. 2 times 8 is 16. Carry the 1. 16 plus 1 is 17. Bring down a 0. 88. 6. 7 and 8 is 15. Carry the 1. 1,056 adults. And then below, I have 84 times 12. 2 times 4 is 8, then 2 times 8 is 16. 0. Bring down the 84. So I have 1,008 versus 1,056. Let me do my decimals while I'm here. I ignored the 2 decimals that were involved in this percentage. But then you have to move to the right 2 decimals. So in the end, I have to move no decimals. That means my answer is true. Same thing over here. I had to move to the left 2 places, but then to the right 2 places, and guess what? I've already taken care of it. Now, what the answer was is how many more adults? So when I do that, how many more adults? What do? We do the 1056 minus 1008. And I think you'll find the answer to be 48. My next one that I want to do is number 18. In this next one, we have Janice bought a coupon book and she already used 33 of the coupons, which is 60% of all the coupons. So how many coupons were in the book? So 60% of all the coupons. So we could let X equal the number of coupons in the book. And we're left with 33 now. So I'll just say at the beginning. So we have that there. And then because now there are 33 coupons in the book now. But I do know that these 33 coupons represented 60%. So what we have is 33 coupons is 60% of all of the coupons. So you can see I've got an equation quite literally like the previous ones that we've done. 60% you could write as 0.6. Divide by 0.6. And then off to the side we do 0.6 into 33. Actually we don't. We move that decimal over 1. We move that decimal over 1. So we're actually going to do 6 into 330. 6 goes into 33 5 times. 6 goes into 30, 50, or 5 times again. 0 remainder means that our answer is 55, and I'll throw coupons. But I don't think we needed that. They ask you how many coupons were in the book. So if I say 55, they will understand that answer because they're the ones that mentioned the word coupons. So you don't have to attach coupons to the answer if you don't want to for this case. My next one, I want to grab number 26 out of the textbook. So now we have Lorena has $54 deducted from her $450 paycheck for carpool transportation to work. What percent is deducted from her for her carpool? So let's see. We could let X equals the percent deducted. Now what do we have? $54 is deducted. So 54 is what percent of 450 is exactly what it's asking us. 54 is how much percentage of her paycheck. So 54 equals X times 450. I'll divide both sides by 450. And I'll have X equals, well, I got to do 450 into 54. Since it doesn't go, I'm going to put my decimal, add a 0. 450 goes into 540 once, with a remainder of 90 is how much that you get after subtracting. And then I'll add a 0 and drop that 0, and 450 into 900 actually goes exactly 12 times. So it was nice to go in terms of decimals here. So we got 0.12, but the question was, what percent? Remember, this was the percent. That was the question that was asked. So I have to change this to a percent by moving that decimal. So 12% of her pay is deducted. That was the first question. There's actually two questions. What percent is not? Well, this is easy. Her whole pay is 100%. Well, if you're using 12% for the carpool, then she has the rest left over, which is 100% minus 12%, and that's 88% of her pay is not deducted. Moving on. My next one I want to do is problem number 30. All right, let's see. In 2014, 21 out of 50 adult workers checked work email while on vacation. What percent is this? Well, that's not too much at all. You're just basically doing 21 out of 500, or I'm sorry, 50. Well, that's 21 over 50. If I want to change it to a decimal or a percent or whatever, I'm going to have to do the long division. So I'm going to do 50 into 21.0, since it won't go into 21. 50 will go into 210 4 times. Add a 0, bring down a 0. And 250 does not, or sorry, 50 goes into 100 twice. And so this equals 0.42, but we have to change it to a percent. So that's 42%. Now, your book specifies the use of proportions to solve some of these problems. And honestly, I am not a big fan of these things, but I'll show you some because they are in our textbook, and probably because some others whose instructors like these things might want to use them. And you might too. Some people do desire or try to solve all of their percentage problems using proportions somehow. So anyways, let's see what this means. Let's see what we have. 94 births is what percent of 470 births? Now, to me, the equation that you could invent starts at what and ends at the question mark. Right there is the equation sitting there waiting for you to write it out underneath of it. Instead, though, we want to know what is 94 out of 470 as a percent. So that equals what percent. So you would like to know, let's say it's X percent. Say this is the information that you want to know. Well, I could write it as X over 100. Remember, 1% is 1 over 100. Well, the way these are always solved is you cross multiply. So you get 94 times 100 is 9400, and that equals 470x. To get x, I'll divide by 470. So I have 470 going into 9,400. I happen to know that 470 goes into 940 twice. And here we are with an empty digit again and 0 in the remainder. What do? We fill that in with a 0 and we get 20. So what's good about this, though, is X was in front of the percentage sign, so X is already in percentage format. So the answer is 20%. So I don't have to adjust the answer because it's already been adjusted while doing the problem itself. One liter is what percent of 1,250 milliliters? Well, you ought to know that 1 liter equals 1,000 milliliters. So we want to know 1,000 out of 1,250 equals X percent. What percent is that? And I put a question mark when I meant to put percent. So change the right side to X over 100. The left side you can leave as it is. I can't help it. I can cancel a 10 easily on the left-hand side and get 100 over 125. There's a lot more simplifying I can do over there, but I don't know. You can either do it now or do it at the end. I really don't have an opinion one way or another. So I'll get 100 times 100 is 10,000. And then 125x. I can divide by the 125. And let's see what that is. 125 into 10,000. Well, let's see. 125 doesn't go into 100, but it will go into 1,000 8 times exactly. Subtract, and I have zeros, and once again an empty spot to fill in, and I get an 80. So 80 equals X. Remember, it's already in percent format, so this answer is 80%. So you can see setting them up like a proportion is sort of, this is like when we solve these equations, this part comes up anyways in them. So I don't see an advantage to doing proportions or not, but don't let me badmouth it. Your book evidently thinks it's a good idea. Let me grab number 40 from the textbook. So let's see what we have here. During the 2014-2015 school year, approximately 9 out of 20 high school athletes in Connecticut were female. We want to know what percentage this was. So at 9 out of 20 equals what percent? And so 9 out of 20 equals X over 100. And so cross multiplying once again, we have 900 equals 200x. I'll divide by 200. I can cancel 100 out of the top and bottom, and I get 9 over 2 is 4.5. I happen to know that off the top of my head. And then we need to change that. Actually, I think I made more of a mistake here. 9 out of 20. I know it's not 4.5%, so I've got to change my answer. I've got to fix my answer. So X over 100, I've got that. So 900. Right here, what I did, I don't know why, but I multiplied both sides by 200. So I'm not really sure what was going on there. So let's get rid of this. And my last line, I got 900 equals 20x. But when I divide by 20, I can still cancel out a 10, and I get 90 divided by 2 equals X. Hopefully you should know that that's 45. So what percent is this? 45%. My next one is number 44. All right, in this problem, we have the U.S. Postal Service is one of the leading employers of minorities. In 2017, approximately two out of its five employees were from a minority group. And then what percent of the employees were minorities in 2017? Let's see what we have here. 2 out of 5 of its employees were from, oh, this is easy. 2 out of 5 is 2 over 5, and we want to know what percent that is. So 2 out of 5 equals x over 100. Cross multiply. I get 200 equals 5x. Divide by 5, divide by 5, and we get 40 equals x. So that's 40%. Next, I want to do number 48. Whoa. Let's see. Doctors recommend that adults get 8 hours of sleep per day. What percent of one day is 8 hours? And then we want to round our answer to the nearest percent. Okay, so we want 8 hours out of the day, so that's 8 hours divided by 24 hours. And that's supposed to equal x percent, still doing proportions. 8 over 24 is 1/3. I'll multiply through by 100. Well, actually cross multiply. And then I'll divide by 3. So I get 100 over 3. I guess I think the best thing to do here is to go to decimals or mixed numbers. Let's see what happens here. 3 goes into 100 how many times? Well, I know 3 goes into 100. Well, 3 goes into 10 3 times. I subtract. 3 goes into 10 3 times. If I can see where this is going, I had my thing there. I think I'm going to go decimals because this is very simple. I keep having tens. 3 goes into 10 3 times. Hopefully you can see that we're going to get 33.3 with a bar over it. So 33.3 with a bar over it percent is my answer. However, now we have to round to the nearest tenth of a percent. So what I'll do is the nearest tenth of a percent. So let me go 33.3. The first 3 is 1/10 of a percent, then 1/100th of a percent, and it goes on forever and ever and ever. The decimal place that I'm interested in is right there because that's the 1/10 of a percent. The next one after it tells me to round down. And I have 33.3% is the answer they were looking for. My next example is number 54. Get back. And let's see, a school computer lab has 55 laptop computers for students to check out. 44 computers are currently checked out. So we want to know what percentage are still left for checkout. So that leaves us with 11 computers are left out of a total of 55 computers. That's how many are left. I'm putting the units just for helpfulness, I hope. Those will cancel out as you do the problem anyways. And this is supposed to equal X percentage. The computers drop out. We got 11 over 55 equals X over 100. Now at this stage, you can, I think I'm going to do it because it's so simple. The 11 over 55 is 1 over 5. I think I'm going to do this. This will make life a little bit easier. I didn't have to, but I'm going to do it anyways. And cross multiply here. I get 100 equals 5x divided by 5. So remember, because we did it using a proportion, our answer is 20%. Does not have to be adjusted for decimals or anything like that. And then the very last one out of this section is problem number 60. I believe it's the very last problem in the section. It sure is. All right, let's see here. We have a survey of 2,500 people revealed that 63% of them would take a train to work if they had commuter rail service in their town. So how many people said they would like to ride a train to work? Well, there's 2,500 people, and 63% of them said they would. So 63% of 2,500 would ride a train to work. And, well, there's not much here to do. 0.63 times 2,500. And I'll do the same game I've been doing. I can do 25 times 63. And my answer I won't have to adjust because the number of decimal places equals the number of zeros in this problem. So I'll just be able to do this straight up multiplication, and whatever answer I get will go right after this equal sign here. 5 times 3 will be 15, carry the 1. 5 times 6 is 30, 31 there, 0. 2 times 3 is 6, and then 2 times 6 is 12. 5, 7, 5, 1. So this is 1,575 people.